Here's a problem from section 4.3 of the book on the mean value theorem. And actually, I really feel like section 4.3, it's more about, what they call the first derivative test than the mean value theorem. So maybe the chapter should have been called the first derivative test. But here's a problem from that section. It says that in this figure, this is the graph of f prime of x, the derivative of a function. And they ask you to find the critical points of f and determine whether the critical points are local minima, maxima, or neither. Okay, so let's just remember that the critical points, those are points in the domain where f prime equals 0 or f prime doesn't exist. Okay, so it looks here like the derivative f prime of x exists everywhere, but for this picture it looks like our critical points only come up because of when the derivative is 0, and those happen to be at the points x equals -1, x equals 0.5, and x equals 2. Okay, and now we just have to figure out, for each of these critical points, is it a local minimum, a local maximum, or neither? Okay, well, we can tell this by looking at the sign of the derivative. So look at -1. When x is a little less than -1, the derivative is positive. That tells us that our function is increasing. And after -1, a little after -1, the derivative is still positive, so our function is still increasing. So near x equals -1, we're looking, the original function, f, looks like it's increasing, then at -1, the slope is 0, and then the function continues to increase. So this occurs when at -1 down here. So this looks like at -1 we have neither. On the other hand, near x equals 0.5, a little less than 0.5, our derivative is positive, and a little after 0.5, the derivative is negative. So when we are to the left of 0.5, our function is increasing, the derivative is positive. But after 0.5, we're decreasing. So we must have something like this, where we're increasing until we get to 0.5, then after 0.5 we start to decrease. So that looks like the local maximum. And finally, near x equals 2, well, to the left of 2, the derivative is negative, and to the right of 2, it's positive. So before 2, to the left of 2, the function, the original function, is decreasing, looks like that. And then we get to 2, we stop decreasing, and we start increasing. Okay, so it looks like at 2 we have a local minimum. So maybe I should just write down the final answer here. That x equals -1. It's a critical point, but it's neither a min or max. At x equals 0.5, we have a local max. And at x equals 2, we have a local